Alright guys, welcome to the Algebra 2 Absolute Value Review. Alright, for 1 through 5, given y equals absolute value of x, change the given function to describe the stated transformations. Alright, so for the first one, vertical translation down 4, so y equals absolute value x minus 4 on the outside. Alright, so remember the form is a absolute value x minus h plus k. Alright, the k is telling us to move up or down, the h is left or right, but you always treat it like the opposite, and the a gives you the vertical expansion or compressions. Alright, so this one's moving down, so minus 4 on the outside, reflection over the x-axis, so we need a negative absolute value of x. So the negative is telling you that the graph is going to flip upside down. For number 3, we have a vertical compression by a factor of 1/3. So y equals 1/3 absolute value of x. Alright, then for number 4, horizontal translation right 3. So y equals the absolute value x minus 3. Alright, so it's the opposite. So you would think plus 3 means right 3, you would think minus 3 means left 3, but it actually means going right 3. So inside, opposite. So remember, IHOD and over. Alright, so inside, horizontal, opposite domain. Over, outside, vertical, exact range. And then reflection over the y-axis. We really didn't talk much about that one, but that's just when there's a negative on the inside. Alright, so given the parent function, what is the domain and range? So the parent function has a vertex of 0, 0, and then it just goes right 1, up 1, right 2, up 2, then 3, 3, 4, 4 on the right side. If you take the absolute value of negative 1, you get a positive 1, negative 2, 2, negative 3, 3, negative 4, 4. Alright, so domain is always negative infinity to infinity. Alright, so it's always negative infinity to infinity. The range for this one starts at 0, so bracket 0 to infinity. Alright, so now let's graph these. So on number 6, y equals the absolute value of x plus 2. So we need to describe the transformation and domain and range. Alright, so this is telling us to go left 2. We have plus 2 on the inside, so we're going left 2. So the vertex should be at negative 2, 0. Alright, there's no expansion or compression, so I could just go right 1, up 1, right 2, up 2, and just follow the same pattern the parent function has. Because when you graph your functions, always put at least 5 points. And again, you could always just graph your function using the calculator. Alright, you could go to math num abs to get the absolute value, type in x plus 2, graph it. That's kind of how our function looks like. Then you could go to the graph, or go to the table, and then you could get the points. So the vertex is at negative 2, 0. And I could just get points above and below that. Alright, so the domain would be from negative infinity to infinity, and the range would be from bracket 0 to infinity. Alright, so now for number 7, we have a reflection over the x-axis. Alright, so the graph should be upside down. It has a vertex of 0, 0. Alright, so there's no h or k, so 0, 0 for the vertex, and then it's just going upside down. Alright, so then again, you could just graph this in the calculator to get the points, but you also know the absolute value of 1 is 1, the negative makes it negative 1, the absolute value of 2 is 2. The negative makes it negative 2. For 3, you get 3, but the negative makes it negative 3. Alright, so we go upside down, but the domain is still negative infinity to infinity, and the range would be from negative infinity to 0. Alright, so be careful with the range when the graph is upside down. Alright, so now for number 8, we have a 2 on the outside, so this is a 2 in the very front, so that's the A value. Alright, so that's the A value. So we have a vertical expansion by 2. Alright, so again, you could just always graph this in your calculator. 2 math num abs x, graph it, second table. Alright, your vertex is at 0, 0. We have a point at 1, 2, then 2, 4. And then the other direction, negative 1, 2, and negative 2, 4. Alright, so this is a vertical expansion by 2, so the graph gets a little bit more narrow. Alright, so everything expanded by 2. So instead of being at 1, 1, we're now at 1, 2. Instead of being at 2, 2, we're now at 2, 4. So everything expanded vertically. Alright, so now for the domain, it's still negative infinity to infinity, and the range would be from bracket 0 to infinity. Alright, so range is from bottom up, domain is from left to right. Left, it's always going to go that direction. Right, it's always going to go this direction. But for the range, from the bottom, we start at 0, and then it keeps going up to infinity. Alright, so then for 8 through 12, we're just describing the transformation. So on number 9, x minus 8 on the inside of the absolute value, that's telling us to go right 8. Number 9, negative on the inside, is reflection over the y. Right, the absolute value of x plus 4 on the outside is telling us to move up 4. 1/2 on the outside is telling us vertical compression by 1/2. So remember, if the A value is greater than 1, it's a vertical expansion. If the A value is between 1 and 0, it's a vertical compression. Alright, so then 13 through 16, we're going to be solving for x. Alright, so step 1 is to always make sure that the absolute value is isolated. On 13 it is, so I could just go ahead and make my two scenarios. So negative parentheses 5x minus 8 equals 27. Alright, so those are the two scenarios. So for scenario 1, it's a two-step equation. Add the 8, you get 5x equals 35. Divide by 5, x equals 7. Second scenario, distribute the negative. Alright, so negative 5x plus 8 equals 27. Now, two steps, subtract the 8. We get negative 5x equals 19. Divide the negative 5. X equals negative 19 over 5. Alright, but we still got to check our answers. Alright, so we go to the calculator, y equals. So for y1, put the left side. So math, num abs, 5x minus 8. Then for y2, 27. And then hit the graph, hit second table, and then let's check our solution. So let's go to 7. Alright, so 7 works. And then for negative 19 over 5, you can't really see it on the graph, so this one we're going to have to plug it in. Alright, so if you type in, let's do this on the calculator. So math num abs 5 times negative 19 over 5, close parentheses, minus 8 gives us back 27. So that one also works. So both our solutions worked. So x equals the solution set of 19 over 5 and 7. Alright, so next one, number 14. Step 1, isolate the absolute value. We have a plus 7 here, so we have to subtract the 7. Alright, so let's make our two scenarios. Scenario 1 is positive x minus 9 equals negative 3. Second scenario, negative x minus 9 equals negative 3. Alright, so for the first one, plus 9, we get x equals 6. Second one, distribute the negative. Alright, so then we get negative x plus 9 equals negative 3, subtract the 9. Negative x equals negative 12. Divide the negative, x equals positive 12. Alright, so now we're going to use this equation to check. So we have to make sure it equals negative 3. Alright, so 6 minus 9 is negative 3. But when you take the absolute value, it becomes positive 3. So that didn't work. 12 minus 9 is 3, but the absolute value is positive 3. It's not negative 3, so neither of them work. So this one's going to be a no solution. The reason you could also tell it was no solution from this part. An absolute value is never going to equal back a negative number. Since this is always going to be false, it's going to be no solution. This is never going to be true. Absolute value is never going to return a negative 3 or negative number. Alright, so number 15, isolate the absolute value. So we have to divide this 6. Right, now let's make our two scenarios. So first scenario, 2 minus x equals 2, negative parentheses, 2 minus x equals 2. Alright, so first scenario, this 2, we need to subtract it. So we have negative x equals 0. Divide the negative out, it's still going to be x equals 0. For the next one, distribute the negative, we get negative 2 plus x equals 2. Alright, and then add 2 to both sides. This is a plus x, so it remains positive x, and then 2 plus 2 is 4. Alright, then again, you always got to check if your answers work. So you always use the isolated one to check your answers. Alright, so I could do this if you wanted to use a calculator. Math, num, abs for y1. So the left side is 2 minus x. So absolute value 2 minus x. Then on the right side is just y equals 2. Right, there's two solutions. And if I go to the table, at 0, they both repeat, so that works. And then at 4, 2, 2, they both repeat, so that's our solution. So they both work. Alright, so number 16. Absolute value is already isolated, so let's make our two scenarios. Alright, so for scenario 1, I am going to subtract the x. And then I'm going to add 10. Alright, so we get 8 equals x. 8 equals x, or you could say x equals 8. Alright, so we got 8 for x for the first scenario. Now for the second scenario, distribute the negative. minus 10. Alright, so for this one, I am going to, let's add the x here. Then add the 10. We get 12 equals 3x. Alright, so last thing we have to do is just divide the 3, so then x equals 4. Alright, so then, well, the last thing would actually be to check if they work. So for y1, I'm going to plug in the left side, so math, num, abs, x minus 2. y2 is just 2x minus 10. Alright, so we see they only intersect 1, so that's telling you there's only one solution. So let's check where that one solution is. So if I check 4, we have 2, negative 2. So that doesn't work. And then if I check 8, that one has 6 and 6. They're both the same, y1 and y2, so that works. So the only solution here is 8. X equals 8. X equals 4 is the extraneous solution. Alright, so then for number 17, now we're going to solve the inequality and then graph the solution set. So it's the same process as the top 4. We have to make our 2 scenarios. Alright, so then let's solve. So first one, subtract the 14. Right, 35 minus 14 is 21, then divide by 7. X is greater than or equal to 3. Second scenario, distribute the negative. Add the 14. Alright, 35 plus 14, that is 49. Then divide by negative 7. Alright, so be careful here. When you're dividing by a negative, the sign flips. Alright, so we get 49 divided by negative 7 is negative 7. So we have x is less than or equal to negative 7. That's going to have a closed dot. 3 is going to have also a closed dot. Then you got to ask yourself, what direction are the x values greater than or equal to 3? So everything greater than 3 is on this side. Everything less than or equal to negative 7 is on this side. Alright, so then for our set notation, or interval notation for the solution set, would be from negative infinity to negative 7, union, bracket 3 to infinity. So again, we're using brackets here because the numbers have closed dots. Alright, so then for number 18, make your 2 scenarios. Alright, scenario 1, add the 1. Alright, so I added 1. Then divide by 2. We get x is less than 3. Second scenario, distribute the negative. This becomes negative 2x plus 1. Now subtract your 1. Right, divide by negative 2. X is greater than negative 2. Alright, so again, you divided by negative 2, so the sign became negative. If you guys remember, on the number line, put these from least to greatest. So the smallest number is negative 2. Alright, so you're putting these on a number line, so it should be in order. Negative 2, then 3. They both have open dots. Everything less than 3 is on the left side. Everything greater than negative 2 is on the right side. So the solution set falls right in between both of right in between -2 and 3. Since they both have open dots, we open and close with parentheses, and -2 and 3. Alright, so then let's go to the last page. Alright, for the last page, they gave us the images, so they plugged in y1, y2 for us. So y1 was x minus 3, and it equaled 4. So this is what they gave us. Alright, so the solutions would be where the two lines intersect. So they intersect right here. Alright, so by just looking at the function, I know my solutions are going to be -1 and 7. Also on the table, you could see that at -1, the 4's repeat, and then at 7, the 4's also repeat. So this equation equals 4 at 7 and at -1. Alright, so you could say x equals the set of -1 and 7. Alright, so now it's saying x is the absolute value of x minus 3 is less than or equal to 4. Alright guys, so when is the absolute value graph less than or equal to 4? So if you look at this, it's less than on the bottom. So then the set notation would be -1 is less than x, or less than or equal to, less than or equal to 7, and then the notation would be bracket, -1, 7, bracket. Now for this one, it says when is the absolute value graph greater than 4? So when is it above 4? It would be right here. So then that notation would be from x is less than -1 or x is greater than 7. Alright, so then in set notation, this would be interval notation would be from -infinity to -1, parentheses, because it's just greater than, union 7 to infinity. That's the end of our review.